morning, students. Today we'll discuss the chapter 4, that is digital transmission. So, in that chapter, discuss how digital data and digital data transmit with some digital signals. So, in the digital transmission, so there is a two conversion, that is digital to digital conversion. Another is analog to digital conversion technique. So, in the digital to digital conversion, uh, so first we sorry. So in this section we see how we can represent digital data by using the digital signals. So in this conversion involves one is the line coding, block coding, and scram. So line coding is always needed for it's mandatory, and block coding and scrambling may be used, may not be used. So it depends upon the situations. So in the line coding, it is the process to converting digital data to digital signal actually. So in that case, it can convert the string of zeros and ones to the sequence of that denoted by ones and zeros also. It's for example high voltage plus it can represent one, low voltage they will represent zero, could be represent zero also. So before discussing this line coding scheme, we have to discuss some common characteristics of this transmission. So, so this is the line coding, line encoding and decoding. So where the sender send the digital signal will be encoded, digital data encoded by digital signal and sent to the link. Decoder receive it and decoded again in the digital data and receive the data. So here we discuss what is the data element or the signal element. So the data elements, actually in the data conversion, our goal is to send the data elements, and the data element is the smallest entity of this that represents the piece of information here. So this is the bit. In the digital communication, the signal element carries the data element here. The signal element is the shortest units that the digital signal. So this data element are actually what we have to send. Signal element what we can send. सिग्नल एलिमेंट्स हम लोग सेंड करते हैं, डाटा एलिमेंट को हम लोग सेंड करते हैं. So data elements are being carried. Signal element are the carriers. So in the next, so we can send these the signal zeros and one, it can be zeros and one, or it can be 1 0 collection of 2 and more bits also there. So we can represent by this. So the one thing, another thing is that here the ratio R is the number of data element carried by signal element. So this ratio is very important here. So this ratio are important for how we send the what is the what type of data element are sent with respect to what type of signal element. By that ratio we can found this. Now what is the relation between the data rates and signal rates? So data rate defines the number of bits per second. So we can define BPS. So it is called bit rate also. And signal rate is the number of signal elements sent per second is measured by baud. So this is baud rate. They also referred by modulation rate also. So our goal is to increase the data rate with reducing the baud rate. जितना data send करेंगे signal cost कम होगा तो इतना ही हमारा digital communication अच्छा है. So this is the signal element versus data elements. So first case is ratio 1. Means one data represents one signal element. So like that. Second case is also there 1 by 2. So 2 signal element is there for one data elements half. Third case rate is 2. So here you see if the R value of R is greater than 1, it will be better for data communication, because if R is greater than 1, so it means the data element is more than the signal element, means you can send more data respect to the low cost of signal. So it will be better for the data communication. So we have to know that the ratio, if ratio it should be more than 1. So next is the data rate and baud rate. So what is baud rate? You can say, see the relation baud rate equal to C into N into 1 by baud. So where N is the data rate, C is the case rate. It may be worst case, best case, and average. Worst case means it may be 1, best case means 0, average case is the half. So here by that we can according to the situation we can use this C. So there is some problem. You can see here the average case is there, so C equal to half, and rest other is you can put it and find this problem. So we go through it. Now, although the actual bandwidth here, the visual signal is infinite. Normally we discussed in the last class, but normally effective bandwidth here is the finite here. So you just note it down. It is required for the next. So if we consider like that one problem, maximum data rate of channel is n max is this. Even the next one does the agree with the previous formula of n max. The signal with L level actually can carry the L by 2 bit per level. If the level corresponding is one signal element, we can assume that it is half, so it may be support. So we already discussed the last section that it is possible only for 2 bit only. So it is the proof that microsyrup is possible for 2 bit only. Now we can consider some goods if we choosing the good signal element referred to the line code. Before we discuss the line coding, discuss some problem regarding digital transmission. The first one is the baseline wandering. A receiver receive the average power signal from the receiver signal. That is called baseline. Use that determine the value the incoming data elements. If the incoming signal does not vary for a long time, suppose we send zeros, combination zeros or ones for a long time, this baseline will be drifted or shifting either in positive side or in a negative side. So thus it cause errors in the detection of the incoming data elements. So for overcoming this problem, the good line encoding scheme will prevent the long run of fixed amplitude. So fixed amplitude को हम change करके उसको long run में इसको eliminate कर सकते हैं. So next is the DC components. So when same thing is that when the voltage level remain constant for a long period of time, there is increase in the low frequency signal. Most signals channels are bandpass and may not be supported at low frequency. So this is required the removal of the DC component of transmitted signal. Okay, so if it is constantly same signal is there, you can not use this DC component. Next is the self-synchronization. The clock at the sender and receiver must have the same bit level. If the receiver clock is faster or slower, that will misinterpret the incoming signal of the stream. Suppose in C, in the first example we sent, this is the original bit, but in the receiver and the C, the 1 is decoded 1-1. So same signal is decoded 2 times. Then again 0. The total combination here is the difference. So where you just go through with some example here. So with this example, we can explain what is the self-synchronizations, effects of synchronizations. So it is a one problem. 1 kVS received the 1000 instead of 1000. What will extract it 1? By that we can calculate it. Total number is 1 kVS also. So there is one simple problem. Now the line coding, other problems. So one is the error detection. Error occur during the transmission due to line impairments. Sometimes error occurs in the line impairments. Some codes are constructed such that the error can be detected. So for example, a particular signal is not a part of the code. So when it is occur, the receiver will know that the single error. So some code is there. By that we can find out the error detection. There is a noise interference. There are some encoding technique that makes the signal is noise or is you can prevent this immune the noise interference. This means we cannot corrupt and stronger error detection. So another is complexity. The more robust and resilient the code, the more complex it is to be implemented. And this the price is often paid the baud rate and required the bandwidth. So if it is complex, it will be more costable. So it should go to the optimum way. So these are the parameter or characteristics to implement the line coding techniques. Now, the line coding scheme. Hmm. Uh, in the live session, I'm not discussing this because of some due to some picture is there. It is required to explain this. That's why I'm explaining here. The line coding scheme, we have unipolar, polar, bipolar, multi-level, and multi-transition. So it is, please note it down. Listen carefully. In our syllabus, unipolar, polar, bipolar, we have to concentrate. This multi-level, multi-transition, we have to skip here. So in that unipolar techniques, there is a NRZ, not return to zero, polar NRZ, RZ, bypass Manchester, bipolar AMI and zero. So we study this. This we should concentrate in the chapter this part on. Okay. So now unipolar. Unipolar. What does it mean unipolar? All signal levels are on one side of the time. That is called unipolar. Either it's above or below. Suppose every signal is either it may be positive side, it may be negative, but in one side. So that is called unipolar type of signal. NRZ, non-return to zero scheme, is the example of this. The signal level does not return to zero during the symbol of transmission. जब transmission करेगा वो return zero तक नहीं करेगा. So that is the main fund of this scheme. The scheme is formed with base and wonder and DC component. And it has no synchronization error in here and synchronization error and any reduction. It's simply but for the power consumption. So ज़्यादा simple है but it's consume more power. So like that, zero is considered like if one is positive, zero is the negative. So when is one, it is maybe either side. We may represent it in the negative side also. Yeah. So this is the unipolar scheme. When it is positive, it is given the positive value, and when it is zero, it is given the return to zero. So that is the main scheme. Now the polar. Polar, the voltage are on both sides. This is called polar. Polar energy scheme can be implemented two voltages, positive for one, negative for zero. So this NRZ, there is the two types, the level L, another is level I. Level L means positive voltage for one symbol and negative voltage for other. Both sides. NRZ I means inversion, that change the lack of or the change a lack of change of polarity determine the value of the symbol. Means one symbol may be inverted in the priority of zero does not. So by that we can represent it. So in that NRZ encoding scheme, if you see, so this is the NRZ L, first one. This NRZ L in both sides, 0 for positive side, 1 for negative side. You can represent 0 for negative side, you can represent both way. So positive for 1 and 0, negative for 0. Okay, it may be sometime you can change also negative for 1 also and positive for 0 also. Okay. So see here, this is the positive for 0 and 1 for negative. The simple one. Next one is, so this is the case, another inversion. If it is 0, positive side. So if it is 0, no inversion. So next is 1 inversion. Next bit is अगर 1 होगा तो inversion होगा. So this black dot is there. It is 0, no inversion. 1 inversion. It is 1 inversion. Again 1 inversion. Again 1 inversion. No inversion. Like that, we can represent this signal. So you just carefully practice these symbols how to draw it. Sometimes exam you may ask different combination is example given in the exam, so you have to draw it. In the NRZ L, the value of the voltage determine the value of the bits. Another inversion or lack of inversion determine the value of the bits. जहाँ पे inversion होगा वहाँ पे वो detect करेगा. So here the NRZ L both are average signal rate and n by 2. So you just go through this n by 2 only, because you just concentrate mainly the how to design these signals. Uh, so these both have a DC component problem and baseline wandering. In worst case, both have no synchronization and no error detection. Both are relatively simple to implement. So it is relatively. Now this is one problem. Problem you may go through, but it's no not so much important. So we'll go through only mainly the techniques and drawing scheme. In the polar RZ, now the polar RZ, that is return to zero scheme, the value will be 0, plus 0 and minus. It will be 0, plus and minus. In that scheme, the main problem with the NRZ encoding of part, the sender to receiver cannot be synchronized. But here, the synchronization is returned to zero scheme. There. Each symbol have a transitions in the middle, either from higher to zero, from the lower to zero. This scheme has more than single transition, 2 per symbol, and therefore required is a wider bandwidth. So here no discomponent based on the self-synchronization. Transit the indicator symbol feels more complex as the last 3, but there is no error detection capability. So if you go through this symbol, so you see if it is 0, it's count to negative to 0. If it is for 1, so it is count to positive to 0. Again 0, negative to 0. So it's return 0. When return 0, it's changed the symbol. Either it is positive to 0 or negative to 0. So this is the polar RZ. Next, polar biphase. Manchester and differential Manchester. So in the Manchester technique, the coding consists of combining NRZ, L and RZ. दो मिला के mix up करके जो होता है, there is a Manchester biphase. Each signal have a label transition in the middle from high to low and low to high and use only 2 voltage. So in the Manchester you see, so 0 means it is look like lower level positive to negative, and this represent negative to positive. So like that, 0 means same again 0 again, positive to negative, like that. So this is called Manchester. So another dimensional Manchester coding consists of a combination of NRZ, I and RZ. Every symbol have a level of transition in the middle, but the level of beginning of the symbol determines the symbol values. Once one symbol pause, the label change or not. So this is the 0. If it is considered like negative to positive, it is 0. Next bit is 1. Then it is inverted. Sorry, next bit is no inversion for the next bit is 1. Inversion next bit is 0. So no inversion. 1. This is inversion. Again, this is inversion. By that we can represent this symbol. The Manchester and different Manchester encoding the transition and middle in the bit is the synchronization. So for the synchronization problem, we use this. So here synchronization problem is reduced. Minimum bandwidth Manchester difference Manchester 2 times the NRZ. So इसमें DC component भी नहीं चाहिए, no baseline wandering also there. So there is can be error detection. Now the bipolar. In the code, here the 3 voltage of 0, plus and minus to represent the symbol, not in the transition in the 0 at the RZ like that. The voltage level of one symbol is 0, other alternative plus or minus. So in the bipolar, that is called MI, alternate mark inversion, AMI. So 0 represents the 0 voltage, 1 represents plus or minus, and pseudo is the reverse. So in that symbol, AMI means 0, 0 if it is positive side 1, again 0, again negative side 1, 1 it means alternate, and 0 means 0. And pseudo alternate is the reverse one. The positive side 0, 1 is goes to 0, again either negative side. So where is the reverse one? So these are the bipolar scheme. So it is better to alternate to NRZ. There is a no DC component based on self-luminance also there. So long run of the 001, no signal transition is the no error detection. So up to this, you just go through for that chapter.